In this short video, we are going to learn how to solve the Cournot model of oligopoly. Let's imagine that Citrus Splash and Tropical Twist compete in the market for fruit-flavored soda. The firms are currently engaged in Cournot competition. They face the inverse market demand curve, 50 minus QC minus QT, where QC is Citrus Splash's output and QT is Tropical Twist's output. Price is price per pallet of fruit-flavored soda. So I want you to notice here, subscripts matter. They're indicating which output belongs to which firm in our oligopoly market. In addition to this inverse demand curve information, we are told that each firm produces soda at a constant marginal cost of $20 per pallet, and that neither firm has any fixed costs. Our goal is to determine the Cournot equilibrium quantities and price in this market. So what do we need to know in order to answer this question? We need the market demand curve, and we also need each firm's marginal cost and fixed costs, or we need information about their total cost curve. How are we going to solve this question? First, we will use profit maximization. In particular, we'll set marginal revenue equal to marginal cost to determine each firm's reaction function. Then we'll find the equilibrium quantities at the intersection between those reaction functions. This will technically be a Nash equilibrium. Once we know the Nash equilibrium quantities, we will plug them into the inverse demand curve to find the market price. Let's solve this question. Here's what we know. We have the inverse demand curve, marginal cost, also information about fixed costs. Our goal is to find the Cournot equilibrium quantities as well as the market price. The first thing we're going to do is we're going to solve for Citrus Splash's reaction function. To do that, we're going to use profit maximization, which means ultimately we're going to set their marginal revenue equal to marginal cost. So we need to start by finding total and marginal revenue for Citrus Splash. Now, I mentioned before that subscripts matter here, so let's take a moment to make sure we understand what's going on. We want to find the total revenue for Citrus Splash, which is going to depend not only on their output, but on the output of their competitor as well. In a general sense, this will be equal to the inverse demand times QC, which is Citrus Splash's output. So filling in what we know, we have 50 minus QC minus QT, all times QC. And then pushing that term into the parentheses, we end up with a total revenue of 50 QC minus QC squared minus QT QC. So that's our total revenue for Citrus Splash. Now we're going to find marginal revenue. The marginal revenue for Citrus Splash is the partial derivative of Citrus Splash's total revenue with respect to QC. We are looking at how their revenue changes as they increase their own output, holding the output of their competitor constant, which is why we need a partial derivative. What is this partial derivative? It can be helpful to identify the terms with QC in them. They all have a QC in them. So the marginal revenue will be 50 minus 2 QC minus QT. Now that we have that marginal revenue curve, we can set marginal revenue equal to marginal cost and solve for QC. I want you to notice that this QC that we're solving for is not going to be a number, it's going to be a function, and that function is referred to as a reaction function because it is going to tell us how Citrus Splash should respond to any output choice of their competitor. So filling in what we know, we have 50 minus 2 QC minus QT is equal to the marginal cost of 20. We're going to solve for QC, so I'm going to shuffle it over to the right-hand side of the equation. I have 2 QC is equal to 50 minus 20, which is 30, minus QT. Now I'm trying to find QC, so I'm going to divide both sides by 2, and I'll have my reaction function QC is equal to 15 minus QT over 2, which I'm going to write as 0.5 QT. And we will call this equation 1. So there's our reaction function for Citrus Splash. Our next step is to solve for tropical twist reaction function. This is going to go in the exact same way as citrus splash, so we'll do it a tiny bit faster. We need to compute total and marginal revenue. Total revenue is going to be equal to inverse demand, 50 minus QC minus QT, all times QT, because now we're talking about tropical twist. Dealing with this parenthetical, we get 50 QT minus QC QT minus QT squared as our total revenue. And then we can find our marginal revenue, which is going to be the partial derivative of total revenue with respect to QT. Again, this is tropical twist's marginal revenue, so we want to know how their revenue increases as they increase their output, holding the output of their competitor constant. What is this partial derivative equal to? 50 minus QC minus 2QT. So we have found our total revenue and our marginal revenue for tropical twist. We are going to set this marginal revenue equal to marginal cost and solve for QT. Just like before, when we solve for this Q value, it's not going to be a number, but instead it will be a function, which we refer to as a reaction function. So filling in what we know, we have 50 minus QC minus 2QT is equal to the marginal cost of 20. Isolating QT, I get QT is equal to 30 minus QC. And dividing both sides by 2, I get that QT is equal to 15 minus 0.5 QC. We can call that equation 2, and that is the reaction function for tropical twist. Now that we have our two reaction functions, we can remind ourselves that the equilibrium has to lie on both reaction functions, which means it must be at the intersection between these two reaction functions. How do I find the intersection between these two reaction functions? I really just have to solve this system of two equations and two unknowns. There's more than one way you can do it. I'm going to solve by substitution. So I'm going to substitute equation 1 into equation 2. That allows me to eliminate C, QC, and solve for QT. So I have QT is equal to 15 minus 0.5, and in place of QC, I put what I know about it, which is that it's 15 minus 0.5 QT. Now I can deal with this parenthetical. QT is equal to 15 minus a half of 15, which is 7.5, minus 0.5 times minus 0.5, which is plus 0.25 QT. Now I'm going to collect all my QTs on the left-hand side of the equation. I have 1 minus 0.25, which is 0.75 QT, is equal to 7.5. From here, I think the smartest thing we can do is convert to fractions. So I'm going to rewrite this as 3/4 QT is equal to 15 divided by 2. I'm going to multiply both sides by 4/3. And when I do that, 4/3, this side cancels, and I end up with QT is equal to 15 divided by 3, which is 5, times 4 divided by 2, which is 2. So QT is equal to 10. So we have figured out tropical twists. We'll call it equilibrium quantity, and now we need to figure out what citrus splash should do. To do this, we will substitute QT equals 10 into citrus splash's reaction function, and that should reveal what citrus splash is going to do. So we have QC is equal to 15 minus 0.5 of 10. Well, 15 minus 5 is 10, so QC is also 10. We'll call that equation 4. So we have successfully solved for the equilibrium quantities for each firm, but we still need to find the price. So step 4 is to find the price using inverse demand. This is just a substitution exercise. So price is equal to 50 minus QC, which is 10, minus QT, which is 10. Price must be equal to $30. So we have our final solution. Citrus Splash sells 10 pallets of soda, Tropical Twist sells 10 pallets of soda, and the market price is $30 per pallet.